Alright, this is the homework that we're going to work on in class on Tuesday. So this is finding derivatives of trig functions, which is fairly easy. You just have to memorize a few of the theorems. So if y is equal to, let's start with the sign, y is equal to sine of x. Okay, we're going to do this without proving it. Okay, then y prime is going to be cosine of x. Okay, and then if y is equal to cosine of x, then y prime is negative sine of x. Every time you take a derivative of co-function, you always want to get a negative for the answer. And then if y is equal to tangent of x, then y prime, okay, is going to be secant squared x. Okay, and then if y is equal to secant of x, then y prime is secant of x tan x. And then we have y is equal to cotangent of x. Since that's a co-function, you know you're going to get a negative answer. Y prime is equal to negative cosecant squared x. And if y is equal to cosecant squared, cosecant of x, okay, let's go backwards. Cosecant of x, okay, then y prime expands to negative cosecant, secant, negative, negative cosecant of x, cotangent of x. Right, so I have a 1, 2, 3, 4, 5, 6. Okay, these are the derivatives of all trig functions. All 6 trig functions, you need to have them memorized, and we're going to do a few problems. Once you memorize those, it's fairly easy. This section's going to be easy. Okay, so let's go ahead and start with some even problems. I'm on page 203. I'm doing number 2. I have f of x is equal to x times sine of x times cosine of x. So sine x times cosine of x. So I am going to use a product rule to find the derivative. F prime of x is going to be first, which is sine of x, times derivative of second, which is negative sine of x, okay, plus second, which is cosine of x, times derivative of first, which is going to be cosine of x. Okay, this is negative sine squared x plus cosine squared x. And you can stop right there, but if you notice, this is actually a trig identity, cosine squared x minus sine squared x. You don't have to go this far. That's really cosine of 2x. Okay, but on multiple choice tests, you'll probably see that. Okay? Alright, so let's take a look at number 6. And then in number 6, they give us an f of x is equal to cosine of x. All that over x times sine of x. Okay, now we have to take the derivative of this. Obviously, we have to use a quotient rule and a product rule. So let's start with the quotient rule. Denominator times derivative of the numerator, which is negative sine of x, minus the numerator, cosine of x, times the derivative of the denominator. But when I go take the derivative of that, I have to use a product rule. So be careful. First times derivative of second plus second times derivative of first. And all that's going to be over denominator squared. And you can leave it right there. You don't have to simplify. Okay. So let's jump to number 10. Let's take a look at number 10. So number 10, I have f of x is equal to secant of x. All that over 1 plus tan x. Okay. Sometimes it's easy to simplify first and then take a derivative, but I think in this situation we'll just take the derivative as is, use a quotient rule. So f prime of x is denominator times the derivative of the numerator. The derivative of secant of x is really secant x tan x. Okay, and then minus, not plus, minus, okay, the numerator, which is a secant of x, times derivative of the denominator. Derivative of 1 is 0. The derivative of tangent is secant squared. secant squared x. All that's going to be over denominator, which is 1 plus tan x squared. It's done, unless you want to simplify. Alright, so let's take a look at the second derivatives, okay, where you do have to simplify a little bit, do some algebra. So let's look at number 20. Okay, number 20, you have a y is equal to cosecant of x, and they want us to find a d squared y over dx squared, which is same thing as f double prime of x, or same thing as y double prime, or y double prime of x. It doesn't really matter. Okay, so we're going to take the first derivative. First derivative is derivative of cosecant x, which is really negative cosecant x times cotangent of x. Then when I take the second derivative of this, I have to use a product rule. I'm going to go ahead and get rid of the negative sign to the outside, so get it out of the way so I don't lose it. Okay, I'm going to set it aside in the front. And I'm going to have to use a product rule here. First, okay, cosecant of x times derivative of second, which is a negative cosecant squared x, plus the second, which is cotangent of x. And then take the derivative of the first one, which is a negative cosecant of x times cotangent of x. Okay, and there it is, and that's the second derivative. Okay, alright, let's do number 24, second derivative 24. So this is 24, and y is equal to tangent of x. Alright, the first derivative, okay, derivative of tangent is secant squared x. Well, secant squared is really secant of x times secant of x. So I have to take the second derivative using a product rule. First, which is secant of x, times derivative of secant of x, which is a secant of x times tangent of x. Okay, and then plus second, which is a secant of x, times derivative of the first, which is also secant of x times tangent of x. Well, it looks like I have two of these, so both the same, so I can just write this as y, this is my y double prime. Y double prime is equal to 2 secant of x, secant squared x, tan x. And that's it. Okay, so I want to do one last problem in this section, so this is going to be a short one. So let's do number 26, where you have to find the equation of a tangent line. Okay, this is number 26. But number 35 is going to be interesting, so I'll let you work that out in class. Number 26, they want you to find the equation of a tangent line with the graph y is equal to sine of x. So y is equal to sine of x at x is equal to pi. I'm doing 26b. Okay, so what two things do you need to find the equation of a tangent line, or any line? A point and a slope. So we have the first value. So how do I find my second value? That's my y, so I'm going to put in a pi right there. So sine of pi turns out to be 0. Okay, now I have my point. I need to find the slope. I take a derivative. That's what slope is. Derivative of sine x is cosine x. Okay, now I have to find out what the slope is at pi. So cosine of pi turns out to be -1. So my slope is -1. Alright, we can write out the equation of a tangent line. So it'll be y minus 0 is equal to -1 times x minus pi. Okay, that's the equation of a tangent line. You don't have to simplify that.